Now, let's see piecewise functions. What we want is to see how we can graph a piecewise function given the rule. The first step that we need to focus on are the restrictions. We take all the numbers out of the restrictions. Here we have the number 2 and the number 3. We consider those numbers and we graph the vertical lines that pass through the points 2 and 3. So x equals 2 and x equals 3. These are the two vertical lines that they will split the entire Cartesian plane into three areas actually, the ones that you see right here. Each one of those areas will correspond to one of the three branches on our function when we graph them. And they will go from left to right as we go from top to bottom on the branches. Then we start graphing each one of these rules, each one of these functions, and start with x plus 3. This is a linear function. In order to graph it, we need 2 points. We need to find those 2 points and graph them on our graph. Now, remember that you should always find the points that correspond to the restrictions. So you definitely want to graph the points at x equals to 2 and x equals to 3. So let's see. The green line that you see corresponds to x plus 3. You can find 2 points, any 2 points, including the number 2, because 2 is the number where the red vertical line shows you that the green line will stop, the x plus 3 will stop. So you really need to find the corresponding point for number 2. 2 plus 3 is equal to 5. So when the x is 2, the x plus 3 will be equal to 5. So the corresponding point will be 2, 5. Then you are going to work on the middle section of your graph and you will graph the parabola. For the parabola you need more than 2 points. Definitely you want the point for x equals 2 and x equals 3 because these are the 2 ending points for the parabola, but you also want an intermediate point to calculate and find the f of x in order to graph it properly. And this gives us this purple that doesn't show very well, but it is a curve. So you will calculate the point for f of x equals to 2 and f of x equals to 3. After you finish the green line and the purple line, you are going to also graph the horizontal line that corresponds to the last branch. Now, note that for that one, all the points have the same y coordinate. And this is going to be equal to 10. That's why the line is horizontal. Again, what you need to pay attention is not only how to graph the different branches, but how to graph the points where we have the change between the branches. So here the point 2, 5 and 3, 10. These are the important points that you definitely want to calculate and make sure that you know if you should include in your graph or leave it open. Three, 10 is the point that you can get it from the third branch. 2, 5 is the point that you get from the first branch. Why from the first branch? Because you have the equality, so you want the x to be equal to 2, and if x is equal to 2, then the f of x is calculated from the first branch. So it's going to be 2 plus 3 equals to 5. while the other point is calculated by the second branch of the equation. Why? Because the equality now is at 3, at x is less or equal to 3 on the second branch. So if you plug in the 3 inside the second branch, then you have 3 squared plus 1, that is equal to 10. And that's why the 3,10 point should also be included in your graph. Now, one thing that you need to remember is that in the previous example that we had an equality on the second branch. While here I'm giving you an example where we don't have this equality. We have less than 3 on the second branch and greater than 3 on the third branch. So the number 3 is not included in any of the branches. Although you need to calculate the f of 3 for those two in order to see exactly where the graphs of the third branch and the second branch end and start, we need to leave this point open and show it with an open circle. Now, what should we do if we want to start with a graph and understand what is the piecewise function, the rule of the function, if we have the graph? In this case, we have two branches. How do we know? We have two different equations, two different lines. And also, these lines, as you can see, they don't connect. Although the one stops, the green one stops at when x is equal to 2, the purple one starts where x equals to 1 actually. What we also see is that the green includes the point x equals to 1, while the purple one doesn't include that point. So what we need to do is to actually find the equations of those lines. But the first thing that we do is we graph a vertical line that passes through the number 1. That is the point where the two lines are separated. So we graph this line in order to remember that what are the different points that we need to calculate and what are our restrictions. The first thing that we write are our restrictions. X less or equal to 1 for the first branch for the green line and x greater than 1 for the purple line. Why less or equal to 1 for the green line? Because the point is included. You see it and it's shaded. While in the purple line, this point is not shaded. It is open. Now we graph the line. We just need 2 points. So I consider the point 1,4 and 0,3. These are the points that they will give me the slope, and also 0,3 gives me the y-intercept. In the same way, I will continue and find the purple line. But let's do this one step at a time. Let's find the rules now. For the green line, we can see that the rule is equal to x plus 3. Why? Because 4 minus, if I want to find the slope, then